Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be looking at evaluating integers with exponents. Before we do that, let's go ahead and get started with our trivia question turned in from my daughter Tara. Why do bananas turn yellow when they ripen? I'll be back with the answer to that after instructions. Tonight officially our target is I can correctly calculate the value of a positive or negative integer with parentheses. It gets messy at times, so let's get messy. Let's do this thing. All right. It really boils down to a couple of things. Well, here's thing one. Can you evaluate this expression? Minus 3 squared. Le penseur. What? What does that have to do with anything? Well, not much. Well, actually, le penseur is a famous statue. It translates as the thinker. So basically, you guys are thinking right now, is this 9 or is this negative 9? If I were to ask you, we'll poll you, about half you would say 9, about half you would say negative 9. And as I talk, you're going back and forth. Is this 9 or negative 9? Well, tonight we're going to learn how you tell the difference between those two and which one is correct. All right, so let's take a look at it in another sense. What if I said, what is 12 minus 3 squared? Would you know how to solve that problem? Auguste Rodin, the sculptor of Le Penseur, would know. He would say, hey, it's just 12 minus 9 because you have to apply the order of operations. He's correct. You have 3 squared here. This is 9. You take 12 and you subtract the 9. So you have to apply the order of operations in this situation. Therefore, it's actually equal to 3. 12 minus 3 squared, or 12 minus 9, is 3. So let's go back to a question very similar to our opening question there. Can you evaluate this expression? Well, minus 5 squared, well, let's think about it. It's minus 25 because you go in, you do the exponent first, and you leave the negative symbol there. All right? Auguste Rodin, take a look at that hair, or that beard on him. Dude, does he look like he could be an MLB player? I think so. I mean, the beards have gotten crazy. I mean, now batting, number 12, Auguste Rodin. What? Okay, forget it. I'm off track. All right, so let's think about this expression here. That was profound, Mr. Dudley. Okay, thanks, Kip. Evaluate this expression then. What's 13 minus 3, the entire quantity squared? This is thing 2, you got to know. What? Okay, I'll help you. Well, really, that's the same as 13 plus a negative 3, right? We could say that, and then we have to square the whole thing. So wouldn't we just say that, well, 13 plus negative 3, or 13 minus 3 is just 10, right? And 10 squared is really the same as 10 times 10. You take everything that's in the parentheses, you multiply it by itself. 10 times 10. 100. You with me? Okay. Then Rex Kwon Do. All right, Peter Pan, tell me what this means then. Okay, here's our first question, that very first one we started with. What is minus 3 squared like that? Well, yeah, I know I put parentheses there, but does it matter? It's just negative 9, right? Apply the order of operations, leave the negative. All right, well, what's this one then? Well, you just take everything that's inside those parentheses and you multiply it by itself. So that's a negative 3 times a negative 3. That is a positive 9. So thing 1 here, minus 3 squared is a negative 9. And this one here, minus 3 with the entire quantity squared, the exponent on the outside of the brackets, that means that it's a positive 9 because it's a negative 3 times a negative 3. Right? All right. I'll give you a couple other ways to think about that too. A couple other things to think about, I should say. All right. How about this one now then? Le penseur is back. Well, let's think about this. Isn't this really here? This is negative 9, right? And this is really, it's like a negative 1 times everything that's in here. So really this can be transcribed as a negative 1 times a negative 9. Well, that's a negative times a negative, so that's a positive 9. Done. All right, well, let's take a look at this one then the same way. Well, let's just write it out. This is what I do. Just write it out. Here's the negative 1. That's a negative 1. And then we've got this whole thing that's inside the brackets times itself. So it's a negative 3 times a negative 3. Well, it's a negative 9 because I've got 3 negative signs, right? Now you're starting to catch on. I mean, if you write out what it means and take the time to do that, you're going to get this right. If you just blindly guess, you got a 50-50 chance of guessing it right. But why not get it right? It's simple. All right. So now it's your turn. Here are a whole bunch of different problems about 4 squared. See what you can do. Go ahead. Did you really pause the video? All right, sounds good. All right, 4 squared. Let's take a look at this. Well, that's 4 times 4, which is 16. Everybody knows that one. And I think by now you've got that this is a negative 16. But in case you didn't, another way to think about that is you could think of it as an m minus 4, so that would be m minus 16. I think it's Sal Khan who says, well, you apply the order of operations, it's 4 times 4, or you could think of that as a 0 minus 4 times 4. Either way, it's a negative 16. All right, how about this one here? It's the same thing. I just added parentheses. You still apply the order of operations. It's still a negative 4 times 4, so that's a negative 16. All right? All right. Next one. Negative 4 times a negative 4, both, because it's outside, so you have to multiply everything that's in the parentheses times itself, so you get a positive 16. This one here. Well, now you've got a negative 16 because it's inside the parentheses, so it's negative 16, add the negative. You got a positive 16 for your product. And this last one down here looks like it should be positive, but it's really a negative 1 times a negative 4 times a negative 4 because that exponent is outside of it. So therefore, you've got 3 negatives. That's a negative 16. All right, I know you want to try it again. What happens if the exponent changes? Well, it's going to change sometimes, right? Because the exponent tells us how many times we multiply the base times itself. So take a look at these. Go ahead and try these. I see dead people. All right, see how you did. Oh, it doesn't want to work. I guess I'm going to have to try it this way. Here we go. I can just slide it over here. All right, so this first one, 4 cubed, that's just 64. Negative 4 cubed, I think you're getting by the chance that this is going to be a negative 64 because it's really 0 minus all of this stuff, or you apply the order of operations, you got 64 and you keep the negative symbol, however you want to think about it. This one here, exact same thing, it's a negative 64. All I did was put brackets on to try to confuse you. Math teachers like to do that. This one here, now we have a negative 4 cubed. So again, we go inside here, we've got 64, and it's a negative 64, so that's how I got this. I'm multiplying it by a negative 1, so now you got a negative 1 times that negative 64, so you got 64. This one here, now you've got that negative 1 times, and now it's outside, so it's everything, the negative 4, everything that's inside the parentheses multiplied by itself 3 times. So when you lay it all out, write it all out, you can see that you have an even number of negative signs, so this is going to be a positive product, a positive 64. All right. You have been a great audience. I hope you can come back to these questions and say, hey, what's this guy worth right here? Bam! Negative 9. Good. What's this guy worth here? Sorry. What's this guy worth right here? Bam! Negative 9. How about this one? Bam! Positive 9. All right. Let's go back to the ticket to the show. Here we go. Give these problems a whirl. And we'll look at them tomorrow in class. And I want you to come back and think about this video. All right, time for the ticket to the show, or time for the just for fun question. Why do bananas turn yellow when they ripen? This is it's a little bit complicated, but I think you can follow it down. There's a lot of science involved. The peel on the banana is green in color, which is due to the chlorophyll content of the peel. Chlorophyll is an efficient way of supplying nutrients, mainly starch, to the fruit inside. All right, so when the starch has been stored in the fruit and it's firm in an optimal condition for eating, right? So then the chlorophyll in the peel breaks down, and the starch within the fruit is converted to simple sugars. That's right, because as it ripens, the banana gets sweeter. As a result, the peel turns yellow because the chlorophyll is leaving it. The fruit softens up and it becomes sweet. And this change leaves the peel much softer and thinner, because you've all had a banana. The black ones, the peels are very, very thin on, right? So anyway, it's easier to peel and it's more delicious that way too. So as the chlorophyll leaves, the banana turns yellow. All right. Thanks so much for listening. Have a great day.